And in the last lesson, you also learned a very powerful command. That's LINPROG. One command with all the parameters and solve all the problems. That's not quite true, but it is powerful. The only problem is, if you use this command, you cannot demonstrate if you really understand the algorithm and the idea. And I not recommend you to use it for the homework. And also, it's too time-consuming and error-prone if you do by hands completely. A good balanced way is you use the MATLAB basic command to solve this linear programming problem, as I'm going to show you right now. So to solve the application of the milk delivery problem, the step one, I would like you to specify the canonical form of the table. That's a matrix. And in the MATLAB command, you can write it this way: A equals 1, 1, 1, 0, 0, 0, 0, 13, 60, semicolon, and keep going. And then you get this initial matrix. I want you to pay attention. This -1 comes from the subtraction. And you can see from the previous example, it's the second table. And this one, we have a negative here. Then you say, hey, how do you get the negative? Remember, the original objective function is like this. Well, we write everything as the equation, and then you can write this equals 0 if we move the constant to the other hand, and then this equals negative 1920, or 19,120. That's how the negative comes from. So remember, don't mess up this step. It's negative. Once you get this step, you need to use your understanding to find the next pivotal element, enable enter base variable and leave in base variable. So how do you identify from the table? See, you can select the X because this is a tire, but this is smaller. Then X is going to be the enter base variable. You identify this column and you divide, and this gives you the least quotient. And then this will be the critical or pivotal row. And the other one is the pivot element. And then which one is going to be the leave-in base variable? And it's this, because that's a base column. So what's next? Next, you are going to use the MATLAB command to make 0 here, 0 here, 1 here, 0, 0, 0. That's your goal. And the operation is clear. You want the second row, the first row minus the second row, third row minus the second row, and so on and so forth. Now let's look at the command. How do you write a row? A row, this original matrix is A. If you put a 1, that means the first row. And all the element, you put a 2, a semicolon like this. That is the first row. And then the new first row equal the original first row the same way minus the second row. That's how you make this first 0 in the first row. If you want to specify column, let's say the second column, you put a 2 pointer here, 2, that will be the second column. And the B3, that's the third column. That's the same idea in the MATLAB. So I want to make 4 zeros. The third row equal the third row minus second row. The fourth row need to be the fifth row. Now the fifth row, you get this 1.4 negative 7 over fifths. To make it a 0, you need to add 1.4 of the 1.4 of the second row. And sixth row, just add. So we achieved one swap. So the x become a base variable, a basic variable. And what left is this. What is that? S3 or S2, I forgot. Anyway, now you can see the halting condition is true. And then you stop that phase 1 and remove, actually this is the artificial one. That's the A. Remove this. Okay, then you can start your phase 2 by the new initial table. That matrix, I call it C. To save my trouble, I did not move this plus column. I just put all 0. That's not bother me, just save me the time to input. I just copy paste. That's how I do it. Or you can just neglect this column because it's all 0. Now I removed the last row, the artificial objective, and what left over is the real objective function. And you got this negative 1.4, which is not the final condition. You need to make this row as the nth base variable and do the division. It's clear this column, because this is the smallest one, is going to be the pivotal row. So this variable should be the leaving base variable. So what's your next goal? Your next goal is to make this 0, 0, that's 1, 0, 0. Okay, let's do it. So I want the first row minus the third row, second row plus third row, and the fifth row add 7/5 of the third row. That's the operation I'm going to do. So again, now those steps in the MATLAB showed me you understand. So when I do all those operations, I made which column? Oh, the fourth column be basic. So now this back into the basic, but the y become non-basic. And this -1 means the y will be the next nth base variable. And then we start to divide. You don't count this because that's negative. And that's 1440, 1200. This one's the smallest one. So this is the pivotal column, row. That's the pivotal column. So your next base variable is the S1. All right. So we do the same thing. I want to make this as 1, all the rest 0. And what you are going to do do nothing for the second row. The third row is going to add to the first row. Fourth row minus the first row. And the last row plus the first row. Then you can make it 0. Well, again, that's better than you do by hands. At least you do not need to do element by element. But to do row by row, what do we get? Now this, again, is base variable. So we are good, because the only thing now in the last row is positive 1. And here's your answer. And what this say to you? This does not count. That's the y equal 1200, and the 1 x equal 800. So the solution again, x equal 800, y equal 1200, and your f equals $168. Same answer. So I strongly recommend you to use those MATLAB commands to do your homework. You can also do it by your test. The only thing you need to be careful is how do you do a row, and that's the row number, a comma, semicolon. So you change from doing one element after another element to do one row by row, and you also showed me you understand it.